Okay, cool. So we're doing something totally different today. Totally different. I've done matter. Basketball GM.
Everything
What up,
okay?
Lizzie? So what we're going to be doing is talking a little bit about the game.
Yeah.
Well, welcome. Um, yeah, we're
Thank
just
you for having me.
yeah, we're just going to jump right into it, and we're going to talk about this code game. So if you could start by telling.
Yes, I'm actually not going to answer that question first. So I'm going to say one other thing first,
Go for it.
uh, which is why are you even seeing this? Why is the source code on GitHub? So most video games you play, you cannot just go look at the source code running everything. And yeah, so basically the reason is because it's more fun that way. Other people can see what's going on, can learn from what's going on, can contribute improvements back. A number of features in the game were made by people just happening to see things and sending me an improvement to the game. Uh, and I think that's really cool. So, although the one caveat is it is not actually open source, you are not allowed to just take this and start a competing video game. But you can take it, run it on your own computer, and for the most part, do whatever you want, except try to put me out of business. Uh, then back to the actual question: what is this built with? It is all JavaScript, and it is all JavaScript because JavaScript runs in a web browser, and you can play the game without downloading, installing anything. You just go there and start playing. It all runs inside your browser. It does not run on a server, which means it costs me basically nothing to run. And yeah, all the data is stored within your browser, which is great, except for when it happens to get deleted and people ask me, can you restore my league? And I say no because it was never on my server. It was only on your computer.
What about the login system?
So the login system really doesn't do very much. So there is a server side component to that, but it only stores achievements and whether you subscribe to the ad-free version. Eventually, it probably should store your actual game data too, but yeah, it doesn't now. Yeah, it would. But yeah, for now, it costs basically nothing because it's not really doing anything. It's just checking logins.
Cool.
But yeah, it might. Yeah.
Very cool. So built-in JavaScript runs front end, saves costs too, and
Yeah.
also makes that it can lots of different devices, browsers, JavaScript runs everywhere. Phone, it runs laptop, it'll run tablet. So
Yeah, that's another main advantage.
uh, so we have this code here, and this is, as you said, this is everything. It's open. It's not open source. It's not available, but it's that you can look at it. And so we're gonna take a bits of their actual application. So we're looking at the top level of GitHub repository, and so it's basically kind of like folder top layer, and then there everything is looking at the top layer where in actual
Yeah, so actual game code, you have to go a couple levels down. So a lot of this stuff is configuration and documentation at this level, but all the code is inside the SRC folder, uh,
so
which I guess is yeah. And yeah, it actually kind of annoys me that you have to go so deep within this folder structure to get to the actual code. So in here, this is basically the entire website. So you have that index.html file. That's what your browser loads initially, and then that points to the JavaScript that that gets run. We don't need to look at that; it's not very interesting. But yeah, and then so basically this is the uncompiled version of what is running on the server. But then all of the code for the game is inside that JS folder, JS for JavaScript.
Okay, so all the JavaScript.
Mm-hmm.
So
And then we have
folders.
Yeah, so there's a lot of folders, and so the two most interesting folders are the UI folder and the worker folder. So probably like 98% of the code is in those two folders, and the reason there are two folders is actually pretty cool, because we have two separate parts of the game that are kind of running independently and communicating with each other. We have the UI part, which is in the UI folder, and we have the back end of the game, which is in the worker folder. And it's called worker because it runs in something called a web worker. And what this means is that the game simulation is running in the worker part of the code. That can happen in the background, and then the UI code is running and displaying what you see in your browser. So whatever's happening in the background in the work, what you like interacting with your browser, it's not going to freeze your browser or anything. And also, whatever you're doing in your browser and whatever your browser is doing to display the page is not going to slow down what's happening in the worker. And that's actually one of the big reasons why the game is faster now than it was like a year ago. Because before, everything was kind of smashed together, and then different parts of the game were slowing down other parts of the game.
And so all the simulation stuff, things with creating stats, and that's all inside of the work.
Yeah. The UI is just about the visualization, what things look like.
Okay, that sounds really. I've into how.
Mm-hmm. Yeah. So then again, we have more folders. There is one JavaScript file here, but that's basically like so that is like the entry point. I mean, we could open that and look at it just because that's where things start. The index.js file there. There's not a ton going on, but just like it's basically importing stuff from all these other files and setting up communication between the worker and the UI. So basically what happens here is the worker process will be started and then it kind of just sits there. It doesn't really do anything on its own. Actions will be triggered from the UI. The UI will be like, give me all the data so I can display the standings page. And then that will send a message to the worker. The worker will listen for that. And then, so that's what this part of the code is doing down here from line 20 on. That's all of
Control.
Actually pretty poorly written code. Yeah, sure. Yeah, I forgot I could do that. Yeah. Let me see. Okay, so I have the mouse. Yeah, okay, so I can move stuff. So yeah, so this is fairly poorly written code right here. It could be a lot simpler, but basically all it's doing is listening for signals from the UI and then calling other parts of the code. And the other parts of the code are things like getting the data to display something in the UI and also running simulation or evaluating a trade, anything that's happening related to the data. So most of the actual interesting things are happening in these folders here. And actually, of all the interesting things, pretty much all of them are happening in this core folder. So the API that's for helping the responses. Those are all functions dealing with responses from the UI. So they're functions to kind of like take the signals from the UI and connect to other things. Yeah, it's I don't need to explain everything. Let's look into the core. So because the core is where most things happen. Yeah, let's get right down to it. And so in here, so these are this is a relatively small number of files, but this is where pretty much everything happens. And the reason there's a relatively small number of files is because these are often giant, huge files. And I probably should break them apart. I've been meaning to do that for a while because it's generally not a good thing to have like thousands of lines of code in one file because it's kind of just, it's a little messier. It's a little more confusing. Things get mixed together. But that is how it is now. So these are just kind of broken down by different parts of the game, like all like in the player file. It's just all different kinds of functions related to a player. Like there's a function to add, create a new player, or to add, when a new season happens, add a new
jump into
stats
that
record.
and take maybe just like
Sure.
one or two functions, take a look at it?
Yeah, although I just seem to have closed it accidentally. Yeah, so a lot of these functions are things that have been around for a while. So, okay, like here's a relatively simple one. So this is a formula that calculates the overall rating. And so yeah, originally it was just taking the average of all the ratings, which is not that great because some ratings are more important than others. So this is a very kind of rough attempt to give different weights to different ratings. We can see like height's very important. A lot of the athleticism ones are very important, 3-point shooting. And yeah, so like, so every time any rating is changed, this gets called again to update the overall rating. And you could imagine a more complicated version of this that might do a better job. Like one of the problems with this formula is that everything it's a linear combination. Linear combination means all the terms are scaled and then added together. So you don't have like free throws times field goals. You can only have like a constant factor times free throws plus field goals. So the problem with that is you can't really capture the interaction between variables. So for instance, if you're a very short player, it doesn't matter if you're really good at post moves or blocking shots because you're never really going to get a chance to use that in a game. So if there's someone who's really short but has a really high block rating, they will be overrated by this formula. And similarly, if someone's really tall and has a really good block rating, then that's spectacular because it's kind of like two things that combine, and the whole is more than the sum of the parts. But this formula doesn't know anything about that. Those two terms are just added together. So maybe someday a more complicated version of that will be made that will do a better job. And that's kind of why some of the times in the game you'll see that there's some players with high overall ratings who don't perform that well, and some with low overall ratings who do perform well, and it's mostly for those reasons.
So is this is something that gets run this on every player at the end of the season? Calculate overall and base, or how does this get the application?
Yeah, so it does get saved to the database, although there's no real reason that that's done because this would be it would be very fast to compute this dynamically. So yeah, and actually, now that you mention it, maybe I'll switch that. Maybe I will have it computed dynamically because the less stuff you're storing in the database, generally the better, because there's less chance for like things to come out of sync, and you don't have there might be less. Yeah, it's just simpler. You want less is more. You want things to be as simple as possible. You don't want to record the same piece of information in multiple places.
Right.
Well, I think
So yeah, that might be a good idea. I actually recently got rid of storing total rebounds. So it only stores off. It used to store offensive rebounds, defensive rebounds, and total rebounds. And for the same reason, there's no actual purpose to storing the total rebounds when you can just calculate it by adding two things together. So now it only stores offensive and defensive, and every time you see total rebounds, it is just combining them on the fly.
Which one is a larger performance hit? Trying to put the overall into the database and writing it up, or getting all of those different player attributes and bringing them down?
Yeah. So, and by the way, for the listeners, that was feather-footed with the question there.
Got feather-footed.
And yeah, so there's no perfect answer to that, which you probably I think you got here is probably what you're getting at. But the way that it works in basketball GM is that everything is already in memory. All the current player ratings are already in memory all the time. So there's no additional cost for fetching things. So the additional cost would be that if you have the overall rating stored in the database, there would be a slight extra time for reading that in and when you're loading things initially, and then a slight extra time for writing that to the database when you're saving things. But that would also be very small because the ratings don't change very much. So it only needs to update the ratings once every season. So in this case, it probably doesn't really matter in terms of performance.
Wait, do you have any other interesting functions here you want to look at, or bounce back out to the?
Yeah, I don't know. Let me just scroll through this. I don't even. Yeah. This is just a huge mess of things. Like for anyone watching, it's like this is not what you should do. You shouldn't put like 50 different functions in the same file. And some of these functions are also kind of too large. Well, I guess that's another thing. You learn as you work on it, and like I've been working on this project for years. The first line of code was, so technically I've been working on it since 2008, but there was a long period after, like I didn't get very far initially, and then I didn't do anything for like 4 years. So I've really kind of been working on it since like 2011-ish, maybe 2012.
And the first line of code was that when Python?
Yeah, that was all Python back then. Yeah, and the JavaScript version was that. So when I got back into it, I think it probably was about 2012 when I got back into it, and yeah, I decided that so to give context for the question, originally it was not written in JavaScript. It was written in Python, and it was a downloadable application. Like you download it, you run the installer, and then it's like a normal application. And I was kind of down on that idea because it's really a pain to make something cross-platform. Like if you want people to run it on like all their different devices, it's very difficult to do. And also people don't like installing things, especially these days. Everything runs in your web browser. Like I was very, I didn't think I was going to ever get very many people using it. So I thought, it might be cool if I could make it all run in the web browser. And that ended up working pretty well. But yeah, what I was saying was, yeah, so like when I started that, I was, not as good at programming as I am now. I mean, I guess as you're working on stuff, you're constantly learning. And there's definitely parts of the code that I would do things differently if I was doing it from scratch. But, if it's not actively causing problems, it can just kind of sit there. And, I might not get around to it for a while. Like there's definitely still parts of the code that are basically like something I wrote years ago, thinking, oh, this is a really stupid way to do it. I'll go back and fix this later. And it turns out to not really matter. Like nobody notices. Like that's true of a lot of things related to the game simulation that are pretty simple. And some of the AI logic that's pretty simple. That just never got revisited, and it's kind of okay. So I guess the moral of the story is
that's how lots of big websites are going. It's just for anybody learning, thinking that maybe that's just not how it's done. But there's lots of big websites that you use every single day that are using bits of code from like 10 or 15 years ago, and it just works. So you keep using it, but you iterate and you update things as needed. And so it's really cool that we can see the code in Basketball GM and how it's evolved. And so yeah, let's take I'd like to hear you explain like another function that you're interested in here, because the player progression stuff is something that everybody is always talking about, or not just a progression, but just players in general. So if we could take another sneak peek at something related to the players, would be really interesting.
We can do that. Although, let me just mention this one first. So this is the function that determines what position a player is. So that's also something that's kind of contentious, because people are saying, why is this guy a forward and not a center, or things like that. So this is the code that does it, and I'm sure it's not perfect and could probably be better, but it's also not horrible. And the positions don't really matter that much in the game, similar to real basketball. And this function, so related to what I was saying at the beginning, this function was not written by me. It was written by somebody else who just said, hey, I think I can make a better version of your position function. What do you think about this? And I thought, yeah, that looks better than what I had before. And then that's what it became. So for people who really, keep asking questions, why is this player's position, blah, blah, blah. If you want to make a better one, you are free to do that. And that would be very welcome. But it's easier said than done, because you have to look at a lot of things, and it's all, there's a lot of edge cases. But so I was asked to look for player development. So so player development is also a very important function. And so we can look at exactly how things work. And so actually, if people have been following what I've been saying in the chat in the subreddit, I am planning on changing all of this, but I don't know when that's actually going to happen. I haven't made a ton of progress other than thinking about it. But as I explain this, you should know that I'm not like totally satisfied with how this works. There's a lot of things that I think should be changed, and you'll probably agree with me. So this is a function called develop, and this is run every year on every player. So all the development happens in the off season at once, which is just kind of a simpler way of doing it than having it continuously happen. And so the way this works is there's no preconceived path. Like you can imagine, if you have a player, when you generate that player as a rookie, you could also generate his career arc, and then each season you could just march along that career arc, and then that would be the player development function. That's not how this works. So the way this works is each time a player improves or declines, each time this function is called, it's fully dynamic. So a player could go up, player could go down. It's just based on his current abilities and his current attributes. And I kind of like that way. Well, it's more elegant, let's say, to do it this way, but it's also harder, and it might actually not be worth it, because then really what you're trying to do is simulate reasonable career arcs, and you're trying to do that without explicitly defining the career arc, which is, of course, is how it happens in reality, but it does make it a little bit harder to do. So let's just look at what happens here. So okay, so this looks a little bit confusing, because this function. So usually when this function is called, it's just saying, it's a new year, so let me do 1 year of player development and see, how I aged over that 1 year. But when you're starting a new league, it's creating players of different ages. So that's why we have this loop here, looping over the number of years. So the number of years is always 1, except when you're starting a new league. And then it will create players of varying ages. But this works because of basically what I said before, that the player development function, it's not predefined. It's the career arc is not predefined. So to do multiple years of development, all you do is run the same code multiple times. So what's happening here is so if a player is 23 or younger, there is a very small chance, 1.5% chance, that their potential rating will increase by a fairly large amount. There is also an even smaller chance, a 0.5% chance, that their potential rating will decrease by a fairly large amount. And that's to like simulate like a draft bust or something, or somebody wasn't as good as he thought he might be. And then this is a very important formula. So this is calling another function, which is defined in another place in this file. And it's computing this property base change. And base change is basically how all of your ratings are going to be changing. So if you get a positive number, then things are going to increase. If you get a negative number, then things are going to decrease generally. And this is based on only two things, which is the age of the player and the difference between the potential and overall ratings. So yeah, this is something that people have had some uncertainty about, like what does potential actually do? Because most players, especially players with a big difference between the potential and overall ratings, most of them don't reach their potential, which I think is also how it is in reality, but it's probably too extreme in basketball GM now. Like it's very rare for these low overall, high potential players to pan out. That is something that I want to change. And it's actually like this because the opposite used to be true. And then when like it used to be true that the high potential players were like, it was pretty much a sure thing. And I had to, make it less likely for that to happen. And I think I kind of overshot it, which is a very common thing that happens when you're trying to balance a video game. It's very difficult to just say, let me tweak this one thing and fix this one problem because, this is a simple example, but it always is going to cause other problems somewhere else. And it's very hard to get everything perfectly balanced. So anyway, so we get this quantity base change, which is a number. It could be positive, could be negative. For a younger player, it's more likely to be positive. For an older player, it's more likely to be negative. And we scale it based on the rank of the coaching spending. So a better coach team is going to get a little boost. A worse coached team is going to get a little penalty. And this is not a big, not like a huge difference. I guess, what does it look like? I guess it looks like it's changing it by plus or minus 25% for the number 1 or number 30 team. And in between would be in between that. And then we have the actual change in the ratings. And so it's not completely senseless. Like there are different ratings that improve in different ways. So first we have like speed, jumping, and endurance. And it says these can increase a little bit, pretty much only when you're young, and they will decrease when you're old. That mostly makes sense. And and then that's what the code inside here is doing. It's basically altering that base change variable based on how old somebody is. And so for an old player, you're pretty much going to be declining in these athleticism variables. So one problem with this that I want to change is that, especially for young players, it's possible for base change to be a pretty large number. So it's possible from somebody to go to like horribly unathletic, really slow, can't jump, to like super athletic. And that's not very realistic. People can make some changes in their athleticism through training, but it's not going to drastically change. So that is something that's not great about this part of the player development code.
Percentage-wise, do you think it's how much more likely is it for a player to go from, let's say if we picked two numbers for overall potential, like from a 20-70 up to their potential versus like a 50-70? And I think that's a situation that players sometimes find themselves at when they're looking at the draft.
Yeah, I wouldn't be able to give numbers without like running a bunch of simulations and seeing, but definitely the 50-70 has a lot more chance. Like the 20-70 it's a real roll of the dice. Like it's pretty unlikely. But but then again, that's the status now, and hopefully like next month that might be different.
Great.
And so then we have other ratings are treating differently than those athleticism ones. So this is dribbling, passing, and rebounding. So these are ratings that can only increase a little bit and only when you're young. And then they decrease slowly. So again, these are pretty similar to the previous ones, but you tend to not decline as much, I think, is what the big difference is. Yeah, like the decrease would be much more slowly, if at all, because if you're a good passer, you don't really forget how to pass. It's more that you kind of lose the athletic ability to put yourself in the position to make passes, but it's not really your passing ability itself that changes. Okay, ratings that can increase a lot, only when young, decrease when old. And I don't know if this really makes sense, probably not. So these these are the ratings where you can see like a huge change within a year. So there's strength, dunking, blocking, steals. Yeah, I don't really know why I did it that way. I don't know if it really makes sense. It's probably just because other things were restricted more. Because you need to be able to improve somehow. And if everything only lets you improve a little bit, then you're never going to have a horrible player become a good player. And that's one of the things that I'm thinking about fixing with some kind of basketball IQ rating, because a lot of young players, I think they might be really athletic, they might already be able to shoot pretty well, but they're not having an impact because they just are not efficiently playing the game. Like they're in the wrong place at the wrong time, they're not making the right decisions, and so there's really nothing like that in the game now. And I think that might be why some of these development things are kind of weird, because any improvement or decline in that needs to be captured in these ratings, which are really mostly like physical ratings or like isolated like abilities, as opposed to overall feel for the game. So we have all the shooting ones too, and these are also not great now. So the problem with this is similar to what I was saying above, is that it's unbounded. So you can come into the league as like the worst 3-point shooter of all time, and then 15 years later, you can be, a very good 3-point shooter. There's no upper bound really relative to where you start, which I think is pretty unrealistic. Like what does happen is people do improve their shooting ability, but they don't go from horrible to excellent. So that is another thing that should be changed, because here it's basically like every year this runs, and actually older players get a bonus here. So older players improve their shooting faster than younger, or not faster, but older players continue to improve in their shooting at about the same rate that younger players do. So that's what this +1 and +2.5 is. It's to account for the normal age-related decline. And so, yeah, it is true that old players in reality can improve how they're shooting, and sometimes do improve how they're shooting, but they don't make big jumps every single year. And that's what's not captured here. And that's kind of related to what I was saying before about not predetermining the career arc. So if you don't have a predetermined career arc, how do you prevent somebody from getting the same bonus year after year after year, and then they go from horrible to great? So that is something that needs to be addressed and will be addressed. And then down here, after we've changed all the ratings, then we recalculate the overall rating. Small change to the potential. Just basically random, making it so the player's potential declines by on average 2 per year, plus a random number. So it could be more, it could be less, could even be increasing. Except if you are old, because if you are over 28, then your potential rating is forced to be the same as your overall. Because if you see a player, roughly over 28, you don't reasonably expect them to improve. They could improve. It's still possible they improve. But so the potential rating is supposed to be, your scout's estimate of what this player's uh, what what this player might become. And for an older player, nobody's really expecting them to improve. And yeah, so funny thing about this. So for some reason, my girlfriend was asking me something about how the game worked, and I was explaining a similar thing to her. And sadly for her, she's almost at the point where she has no potential left, and she's just how she is. And once she crosses that 28-year boundary,
Oh boy,
it's yeah, it could be tough.
how you get in trouble because of the stream.
And so down here, similar stuff. So okay, so then this is also computing the skill labels, those like little letters that appear next to a player. Those are all derived from the player ratings. And that's about it. That's player development. So it's actually quite simple. There's not like a lot going on. Because there's not a lot of complicated formulas really.
Yeah, that was.
But then again,
Oh, go ahead. Go ahead.
Yeah. No, I was just gonna say like yeah, like it's also it's not yeah it's not great. Like it could be better, but then again like it's not horrible either.
But yeah, that's it. That's all the magic. So when people are asking questions, why do players do this or why do they do that? They can see it right there. It's it's not a novel. It's pretty interesting to be able to go and just kind of read through and see how things develop. So this is the player um the player module that has all of the things related to players. Did you want to pull out of here and take a look at another worker, or was there anything else related to the workers that you thought was interesting?
Uh yeah, probably. I mean, yeah, the game simulation code is another big one. Um, yeah, that's probably the other part that's most interesting
Yeah, let's take a
to
quick look
people
there, and
or
then we'll
most
go to
important.
the to some of the UI stuff. And yeah, I'm interested in this as well.
Yeah, so the game simulation code, a lot of the game simulation code is pretty old. And part of that is because I'm kind of like terrified to change this because I don't want to make things worse. So, because yeah, the whole game simulation thing arose in the same way I was talking about before. Like I just kind of made some like very simple thing and thought like, I'll come back and make this better later. And to some extent I did. Like I did make improvements to this later, but it's still missing a lot of things. Like there's no sense of game situation. Like your star player will be on the bench at the end of the game if he's tired, and he's tired because the coach isn't really planning out. I need to rest somebody at this time to get him back in the game. There's all kinds of simplifications in here um, to kind of make it simpler. Like the defense is is simulated in a very simple way. It's basically like a team aggregate value. There's no concept of individual defensive matchups, sadly. Uh, but the beauty of it is that people, despite the fact that some things are not in the game, people will kind of imagine them as being in the game because when you see the results, it's not immediately obvious how everything's working. And the human brain is very good at finding patterns and randomness. So people will often ask me questions about game simulation, and my answer is, or like anything related to the game, my answer is like, yeah, it's just randomness. Like that's not in the game.
I scrolled ahead
So
a bit. I
this
already found a feature request. Looks like in home court advantage,
uh,
the factor only goes up by 1% plus or minus. I
yeah,
think that should totally be based on game attendance.
yeah, that could be true. But I wonder if that's true in reality though, Because so I would want to at least check if it's true that different teams have different home court advantages and that it does seem correlated with attendance. Because the whole idea of home court advantage is kind of mysterious. Because like these are like, grown men who are being paid millions of dollars and are used to being in the limelight. And why are they going to be drastically performing differently based on where they are or how the crowd is cheering? But it's a little surprising to me that home court advantage exists at all, but it definitely does.
Could be a player to player thing as well. When you see like how focused Kobe is on the game, he doesn't let outside things interfere with him, and there could be some players that are a bit more intimidated by the noise or people yelling things from the crowd and other elements. So there's a lot of layers to that as well.
Yeah, I don't know what it is, but it's like it's a pretty big effect too. I mean, and not just and that goes across. I think pretty much every sport. People have seen a pretty big home court advantage. So basically, the way that game simulation works is this part of code runs at the beginning of every game. That's just it's setting up some variables, and the most interesting one is this DT variable. This is the amount of time that each possession takes, because pretty much the way that the simulation works is that every possession takes exactly the same amount of time, which you may have noticed if you look at the live game simulation. So yeah, I know that doesn't really make sense, but it in terms of the aggregate stats, it doesn't really matter for the most part. So what we do is we calculate the number of possessions all the way at the beginning based on the pace ratings of the teams, and the pace ratings are based on, I think, mostly athleticism, how fast your teams play. And then that number of possessions is the number of possessions that are going to be in the game. So every time you see like a buzzer beater at the last second or something, it's kind of completely artificial that possession existed. Your guy wasn't rushing the ball up the court to get the shot off. It was predetermined that you are going to have a full possession. The game always ends in a full possession. Yeah, this is the home court advantage. This is where the home court advantage is applied. Basically, a 1% bonus or penalty to every single rating, and that seemed to produce about the kind of performance difference that you see in the NBA in terms of like a point differential. Okay, so then after the game's set up, this run function is called, and this will simulate the whole game. So we'll get to this later, but yeah, calling this one function simulates the entire game. We can look at that in a little more detail. But then after the game finishes, what if it's tied? The game could still have to go on. So then we will do an overtime here, and this will run until, so the while loop basically means this will run until the points are different. So we'll keep playing overtimes until the scores differ. So in theory, this could run forever. The basketball GM game simulation is not deterministic. It could never complete.
Exciting.
And then this is mostly nonsense related to getting the output. But here, sim regulation. So this is that function that was called before. And yeah, so this runs 1 quarter at a time. So while there's time on the clock, it simulates a possession. And then after the time runs to 0, then it says, let's move on to the next quarter. And then this is just like, stuff that needs to happen at the end of the quarter, like, set the score for the next quarter to 0, record that, a new quarter starting, and then this will run again. And this will run 4 times, because when it's the 5th quarter, it will stop, because there is no 5th quarter. And then a very similar thing happens in overtime, in the sim overtime function. It's still calling this sim possession function until the time remaining goes to 0. So then we can look at sim possession. So yeah, you can see this is kind of There's a lot of functions here. There's a lot of nested functions. It's a function calling a function calling a function calling a function calling a function, which is perfectly okay because we have relatively small functions. It's kind of easy to see what each one does. So in a possession, we take some time off the clock. We have another function that actually runs the possession. And then this is mostly doing like accessory stuff, like seeing what players are on the court, switching offensive and defensive teams. When that happens, keeping track of playing time, seeing if someone gets injured, seeing if substitutions need to happen. But then we have this yet another function, get possession outcome, that determines like what actually happened in the possession. Was a shot made? Was there a turnover? You know. Yeah. Then this is the substitution function here. So this runs. I think it doesn't run every possession, does it? Yeah, it doesn't run every possession for performance reasons. But I forget what the number is. Every certain amount of possessions, it'll check and see if a sub is needed. And basically, the way this works is it will. So every player has a certain value associated with him, and that's roughly supposed to mean how good he is. And when you're playing the game, players get fatigued. So basically, their value will slowly decrease over time based on how fatigued they are. And if there is a player on the bench whose value scaled for fatigue is better than someone on the court's value scaled for fatigue, then the substitution will happen. So it's kind of like a robotic coach saying, you know, this player I expect to perform 2% better than the other player because the other player on the court is tired. So I will put in the player from my bench.
And does it always do that greedily?
Yeah.
So then I guess
it does the first one, it finds the first guy on the bench. Is that what you mean?
Yes, but more so where I was going with that was asking from their fatigue on the bench. Does the rate of recovery exceed the rate of fatigue decrease?
I don't remember.
Yeah, because the deep high level question there is from the perspective of RoboCoach. Does RoboCoach would RoboCoach see value in leaving a star player on the bench for a little bit longer to get them back up to full endurance per se, rather than immediately putting them back in as soon as their proportional value of fatigued overall is better than whoever was, whichever bench warmer was put on the court?
Yeah, that's a good question. So currently RoboCoach would just sub you back in as soon as you're better than someone who's on the court. So he would leave his star player in some kind of intermediate, somewhat fatigued state and never let him really recover to when he's feeling really good. And it's definitely true that might not be a good idea because like not everything in the game is linear. So by that I mean there could be a greater reward for waiting a longer time so that you can play at your peak effectiveness. But yeah, the coach is very naive and is not aware of that.
Yeah, that's probably something that would fall under the situational gameplay that you were referring to earlier. Because I mean, at the end of the day, there's no individual matchups anyway, so it's just that player is contributing to the overall. So RoboCoach is just trying to maximize the overall value.
Yeah, but he's maximizing the overall in the moment, which is not necessarily the same as overall for the entire game. Because it's not necessarily linear. And I was going to say something else, but I forgot. Oh, what I was going to say was the fact that the coach is really stupid is somewhat mitigated by the fact that everyone has the same coach. So it's not like any team is gaining an advantage over the other team because the coach is doing something really stupid. All the coaches are doing stupid things and they're doing similar stupid things. So it's at least the level playing field. And this code I have on the screen now is just ensuring that there's some very broad positional balance in the game. that it won't put like 5 centers in at the same time. So it used to do that. So this is a more recent part of the game simulation code. So the coach's intelligence is improving. He'll no longer play 5 centers at the same time. And I think, well, as far as I know, no one actually noticed when I made that change, because you don't really notice stuff at that level. If you're just looking at the box scores, you might notice in the play-by-play, but yes, all kinds of other stupid things are happening too. So
yeah, I think that mostly manifested as people posting, their league of big men, 5Fs as the starting roster sort of thing, and they're like, why does this even succeed?
Yeah, which you can still do. So I never really fixed that. So that's also one of the things that I'm going to fix when I change how player ratings work. So my hypothesis for why that works is because there's too many tall people who are highly skilled, and in reality, there's just not that many tall people who are great passers or great ball handlers or great shooters. And it's the problem I was saying before, where if you get lucky, a tall player will improve every single year. And he might improve his 3-point shooting 5 years in a row, and then he becomes a great 3-point shooter. And maybe there shouldn't be so many tall people who are so skilled. So it's not something that can be fixed in the game simulation code itself. You can't just give a higher preference to skilled players, because there are a lot of tall skilled players. There are too many tall skilled players. You would have to do really nasty things like penalizing people based on their height, which is, that would be very, very strange and confusing. Okay, so here's another function here, update synergy. So this is my attempt to have the simulation reflect some of the interactions between players. So by that, I mean, if you have multiple 3-point shooters on the court at the same time, that helps your offense in general. It helps you more than just the fact that these people can shoot. It kind of opens things up for everybody else. The same thing if you have multiple athletic players, you can play more pressure on defense, you can get out in transition. But for other things so interior defense is a different type of example. So if you have like 4 great interior defenders on the court at the same time, it doesn't really help you out that much, because not everybody can be guarding the rim at the same time. You really pretty much only need 1 interior defender. So so these things are calculated down here, basically by computing sigmoidal functions based on the ratings of your players. And so the sigmoidal function is basically something that looks like an S. So on the x-axis here, so if we can visualize a graph. Sorry, I can't draw things. Visualize a graph. I probably could draw things, but I don't know. Well, I'm just going to explain it. So on the x-axis, you have like number of players who can shoot 3-pointers on my team. And on the y-axis, you have a bonus. So if you have 0 players, you get 0 bonus. If you have 5 players, you get the full bonus. But in between, it kind of looks like an S. So if you have like 1 player who can shoot 3s, it's not really much of a bonus. But going from 1 to 3 players, that's a pretty big difference. And going from 4 to 5 players probably doesn't really help you that much, because there's only so much room behind the 3-point line. You do actually need someone inside the 3-point line sometimes. Although I guess some NBA coaches might disagree with that at this point. So the sigmoidal function allows that to be represented. So you basically have a period of gradual increase, rapid increase, and then gradual increase. And the range where that rapid increase happens, that defines how many players contribute to this. So for 3-point shooters, it might be from like 1 to 3. But for interior defenders, it might be from 0 to 1. Because if you have 0 interior defend, that's pretty good. That's about all you need. And then, so these are all, I call these things synergy. And they go to they go to the overall offensive, defensive, and rebounding abilities. So it's all meant to simulate things that help other things. So if you have an interior defender, it helps your perimeter defense too, because now all your perimeter defenders can play a little more closely to put a little more pressure on, because if they get beat off the dribble, it's okay because they have a good interior defender behind them. So all these things are used to give like a broad improvement to offense or defense or rebounding. Yeah, I'm going to skip some of this. This is where players get injured.
Our most favorite time of the year.
Yeah. All kinds of good stuff happens here. So I guess this is kind of injuries. So it's not kind of interesting, not kind of injury, kind of interesting. Because the way that injuries work is every player is exactly the same. Every player has an exactly constant rate of injuries that happen per minute played. So the more a player plays, the more likely he is to be injured, but it's not because of fatigue. It's not because he's old. It's just because he's playing more. So that's possibly something that should be changed. But again, it's one of those things that like you don't really notice that it's not realistic for the most part. You can get away with a simpler thing. So that's here. This is their rate per possession. I think, yeah, this is their injury rate per player per possession. And so all this does is mark a player as injured. It does not say what kind of injury it is. So that happens in like another function in another part of the code. So when the results of the game are being saved to the database, only then does it determine what kind of injury it is. Which I guess is kind of realistic, because when a player gets injured on the court, you don't always know exactly what it is. But in here, you have absolutely no idea. It could be, like a minor sprained ankle, or it could be like a torn ACL. You will not know until after the game. Okay, so here's the get possession outcome. This is the function I was talking about before that actually runs a possession. So first we see if there's a turnover, and if there is a turnover, then basically this will track the turnover. If there's not a turnover, then somebody's taking a shot at the end of the possession if there's not a turnover. So we'll see based on player usage, we will pick a shooter. And so usage, so as you may have noticed, there's no like usage rating in the game. The usage is just derived from the shooting rating. So the better shooter somebody is, the higher his usage rating is. So again, this means you can't really represent a player who's a really bad shooter but takes tons of shots, and you can't represent a player who's a really good shooter but doesn't take many shots. That is a limitation of the rating system. That's a separate discussion. The point here is that it picks someone to shoot.
Cool. So that was the get possession outcome.
Yeah.
Okay.
Yeah. So pick someone to shoot, and then it shoots. Yeah.
Let's
Oh,
go ahead. Finish.
Yeah. Is this getting boring? This might be getting. This might be getting boring because it's just function of like.
I was just gonna say wrap up whichever function you're at here, and then let's jump over to the view stuff because we're coming up on an hour here.
Okay, sure, yeah. So from here, it's basic. It's just it's random. It's functions and random numbers all the way down. It's just functions calling things that does this player shoot? Pick a random number and see. Does he make the shot? Pick a random number, compare it to a shooting rating. Who gets the rebound? Pick a random number, compare it to their rebounding ratings, and that's it. And it's pretty simple code. Like there's not a lot of sophisticated stuff going on there. So
I'll try to interject one short question.
Yeah,
of all the stats that people have complained about, probably assists is the one that stands out most in my mind, as people saying that it seems lower than it ought to be.
Yeah.
Now I know that. Well, so I guess my first question then is, if everything else seems to be on the nose, why do you feel like users are noticing a lack of assists?
because I think the total numbers assists is about correct. I think it's just the league leaders tend to be a little lower than what happens in the NBA today, and yeah, I just haven't gotten around to changing that like I could. So it's just assists are more evenly distributed in basketball GM than they are in the NBA.
Okay, and that's exactly where I was going to go. The second part of the question was then, given that basically this thing tries to just allocate it to whoever's on the board, would it make more sense to try and clump them together? Like whoever's gotten an assist is more statistically more likely to get the next assist.
It might. So it doesn't do anything like that. So now every possession is completely independent, and there is some like nonlinear scaling of the assist rating. So somebody who's has an 80 assist rating gets more than twice as many assists as someone who has a 40. But it probably needs to be a little more nonlinear. That's kind of what I was thinking I would do. But yeah, you could imagine possession to possession dependence. I probably am not going to do that because that would make things more complicated.
Make it expensive, yeah.
It's a nice simple model if you can treat everything independently.
Cool. So we just went through the worker. That we were in the worker. It was called the worker folder or?
Yeah.
Yes.
Yeah. And inside the worker folder was the core folder.
Core, and that's where all of the gears are grinding away that do player updates, game simulation, all of that stuff that changes the stats and stuff like that are in there. And so now we're going to switch over to the UI, which is basically just representing all that data, right? Nothing changes data here. What we're looking at now is just representing that data for the user, right?
Yeah. So there's a nice clean separation between the front end and the back end here. So the front end does not know the database exists. It has no concept of the database. It's just sent things from the worker and it sends things back. But nothing in here is actually directly editing anything, which is so in general in programming, it's nice if you can compartmentalize things and you don't have functions where tons of different things are happening. So in one common place to break that is to have the UI separate from the back end. And that was not true in basketball GM until earlier this year. And the reason being that in some sense, the entire thing is the front end because it all runs in your web browser. And so most people writing JavaScript that runs in a web browser have it communicating with a server somewhere. And I didn't have that. So I kind of just smashed everything together into one place. And what that ended up doing was making it difficult to optimize things by what I was talking about before, where I have some things run in the background and some things run in the foreground. When everything was all combined, it was impossible to do that. So I had to spend a lot of time separating those things. So in retrospect, it would have been nice if I had kept them separate in the first place. And that's generally a good thing to do. You don't want functions that are doing everything. You want simple functions that are doing a limited number of things.
What was the old bottleneck on before the split? Was it mostly on database I/O or on computation of so many different things?
It was so for reasons that aren't entirely clear to me, but has also been noticed by at least a couple other people. If you use IndexedDB, if you're using it intensively, and you're also doing things in the UI, it becomes very, very slow. And if you do the exact same thing with the IndexedDB running in a web worker, it becomes much faster. And I don't know if that's something that is fundamental about the web platform, that has to be true, but it is true in all the browsers now. And that was actually the main cause of slowness. So most of the time when the game was simulating, most of the time was the browser basically really poorly optimizing the code that was running and constantly switching between doing different things and confusing itself. And so once I got rid of that by manually separating them and having one thing run in the worker and one in the UI, then everything got way faster.
Cool. Let's take a look at some of the code that actually shows things there.
Yeah, sure. I can open up. So first, let me just open up this index file. So this is kind of like a mirror image of the index.js that was in the worker folder, where it's really just setting up the communication with the worker. And one other thing that happens here is all of the routes are defined. And the routes are, all the URLs. So every single page is defined here. And every single extra parameter that a page can get is defined here. And then each one of these will link to another file in another folder. And actually, I'm gonna open the worker folder back up again to show two things at once. So we have a views folder in the worker, and we have a views folder in the UI. And there are a very similar number of files in here with very similar names, and that is because they're two sides of the same coin. So you have in the UI side, it's everything related to how am I going to display the data, and on the worker side, it's everything related to how do I retrieve the data and format the data for the UI. So like every time you click, it will call one of the worker functions, get the data that you need, and then send it to the UI, and then one of these functions is called. And we can look at one of this. One of you guys want to suggest something to look at in the UI, or should I just pick something randomly?
The player page. Players are always the focus of everyone. So taking a look at the player page would be cool.
All right, actually, let's not do that one first because that one's complicated.
Okay.
Let's do the standings. Maybe the standings are less complicated. So so we have and this isn't the simplest one. It's like a couple hundred lines of code. But the more complicated a page is, the more code's going to be involved. And I'm going to kind of start at the bottom and build my way back up. So this is written using React, which I think is a very nice library for building UIs. What I like about React is that it kind of forces you. It's really hard. It makes it harder to do really stupid things. It makes it harder to write messy code. It makes it harder to write unorganized, complicated code. It really does a good job of forcing you to write simple functions that don't have that don't have weird side effects. That just take some input, produce some output, and that's it. And that makes things a lot more easy to work with. So this is kind of the wrapper of the standings page. So it's displaying both the division standings and the conference.
Are you talking right now? I can't hear you, so I imagine us can hear you.
Yeah, it sounds like you cut out halfway through that sentence.
Does that matter? Can you hear us?
I think we have to assume it was a freak power outage.
Yeah, I'm pinging him. Chat here. I don't know if he's aware. Yeah, so we're having a little bit of a difficulty here hearing Dumbmatter. Maybe you can see that if I type it into the text box. almost thought I heard something. Can you hear me? Dumbmatter. We're
Yeah, I can hear you. Can you hear me?
Yeah, I can hear you.
You're back.
Okay. Yeah, I was having trouble pressing the back button, and I gave you control, so you can open up the player file if you want.
Okay, I'll let you take control again. So
All right. Well, can you switch to the player file because I was trying to go there and I was struggling. Yeah. No, in the other window, in the UI one, or where?
where?
Oh yeah, I guess we can see one of these too.
Do you want to just do standings or?
Let me take control. I'll
yeah,
try.
yeah.
I'll try.
Go for it. I think he's got it.
Okay, so I'm back in control. So yeah, we'll look at the player page. And actually, let's also look at the back end of the player page. So this is pulling in all the data that is eventually displayed. So this is actually a pretty simple function as they go, because all it has to do is gather a bunch of information about a single player. So all the player's attributes, ratings, stats, yeah. And then this is all the data that gets returned. So it's the player plus a few accessory pieces of information, like is the player a free agent, is the player retired, is the player injured, and those are like all related to little things that get displayed within the player page, like the little injury badge or the trade for button, or yeah, if his current age is shown or it just says retired. So all that data gets sent to the UI. And then this is a much more complicated page than the standings page. Let's, if I can see how big, yeah. So this is 800 lines, which is probably too big. And I don't know why everything's red.
Looks like there's a syntax error on 524.
It's probably a bug in GitHub.
Probably, yeah. So the reason it's red is because it thinks that it's a unclosed string literal.
Yeah. Yeah. So this should not all be red. That would be a bug in GitHub. But so this is so although this is one file, but it's broken down into multiple different functions to display different parts of the player page. So sorry, I'm struggling to scroll with the delay of controlling another computer. So this is like the block of ratings that display in the top right of the player page. And so it's just a function that takes the ratings and then creates all these HTML elements through React. And yeah, same thing. So for statistics, so this is the code's, this code's not so bad because each in the player page there's multiple statistics tables, and they are generated from the same function. So it's just the same functions called twice. Like for the regular season stats and the playoff stats, it's just the same function called twice. And this uses this thing called data table, which is another React component that I wrote, and that's what's used to display all the tables in the game. So where things have like sorting and filtering and searching and paging, those all come from the same place, from this data table that I made. And yeah, so actually I think this is maybe not the most interesting thing for people to look at, because it's really just displaying data. So
and that's
everything's
cool.
already gathered and formatted.
Yeah, so basically you have these individual these files, and these files have React code that generate the front end HTML, and so that's how we see everything. And so they don't do too much. They just get passed in the data, and they know what data to expect, and so it displays the data based off of what you pass into it. And so each of these views also has a corresponding backend file that is responsible for getting the data. And so you have this distinction, this abstraction between something that gets the data from the database, and then it passes that to these front end components. And these front end components, their only job is to just take whatever they get and to display it. And so you just have lots of that, right? It's not as interesting because things aren't changing too much here. It's just how do we represent things on the screen to the user. And so that's
Yeah.
it's not the most interesting part, but that's what we're looking at right here in this UI folder. All of this is how do we show the data to the user.
Yeah. And the fact that not much is happening here, that it's just taking some things and displaying it, is actually really nice because it makes it a lot easier to work with and to understand like where things are coming from, where things happen, what functions do what. And and like I was saying before, prior to this year, it didn't work that way, and it was a lot more confusing. So it's much nicer now.
Cool. Yeah. So that's, I mean, that's pretty much it. You have the stuff that happens in the background, and that generates all the players, stats, the games, all of that stuff. And then we have this new area that is just there to display it. So that was a pretty good run through of how things are organized. Was there anything that you wanted to cover? Any sort of a small tidbit of code or a section of code, just that you wanted to look at or show off or talk about?
Uh, Not off the top of my head, but what I would say is if anybody wants to see more or wants to play around with this on their own, I have no idea how many people are listening to this, maybe no one.
You've got 5 people.
Oh, we got 5 people. All right. So if you can go to this URL up here, and it's linked from various places, or you could probably Google it, Basketball GM GitHub. If you go there, so if you've never used Git before, you would probably have to you can even just download all the code here by pressing this button. You can download the code. If you use Git, then you can use this URL to get it. And then once you have the code, there are instructions down in the README file, which is what's being displayed here. So this README file is being automatically displayed down here. There's this for how to actually run the code. If you wanted to take this and run it on your computer, you could do that. You could take it. If you just want to play around with things, look at things, and there's some description about how things work. Maybe a couple of similar things to what I said. Like if you're totally new to JavaScript and web applications, it would probably be a little overwhelming because it's kind of a large. But feel free to look around, poke around, and maybe even make some improvements to it.
Cool.
And yeah, I think that's about all I have to say.
Feather, you got anything you want to add to this?
Not particularly. I do find it kind of funny to see when users post in the subreddit about something new they've noticed, or something that we put in there a long time ago and people are only just now noticing.
Yeah, the ways of players dying is a big one, definitely.
So
you can put a clever joke in there. It takes like 2 years for somebody to notice that it happens because it's so rare.
Somebody does have a question for chat.
Okay.
Asking.
Sure, I can. changing the name frequencies in the college basketball game.
Well, I think he's asking about BBGM.
That one?
Yeah.
Yeah, yeah. So that's using a forked version of basketball GM, and I don't remember exactly when the fork happened, and it might be different than basketball GM. Yeah, the real answer is I don't remember.
Okay.
But
yeah.
So all the other sport games, they are not on GitHub currently. So it would not be so you couldn't really do the same types of editing as you could to basketball GM. And yeah, ask my coder if you have thoughts on that, because he's the one making them. So that is up to him.
Going back to the Zen ones, it really depends on whether they were forked before or after the great name change that actually started using the parse names from the site. Basically, I remember the old one was, you know, a lot more uniform in the sense that it basically had a big old list of first names and a big old list of last names, and it wasn't broken down by country at all. And so
it definitely wasn't broken down by country, but it still might have been possible to customize it. I actually think it was possible to customize it, but the format was different because it wasn't broken down by country. But I also think it's a feature that basically no one used. I don't think I ever saw anyone use it, but you can specify the names in a league file. You definitely can for basketball GM, and I think you can for the other ones too.
Yeah, and of course, like we said, it really just depends on what they're using over there.
Yeah.
Great. So that was really cool. That was really helpful for me as somebody that's trying to learn more about programming and loves playing the game and would love to dive in and poke around with stuff and, you know, look at values to change. This was really good for me. So I do appreciate it. And I hope everybody that was watching or will watch this really appreciate it as well. And yeah, so we got a good hour and a half in, which is really good. But that's gonna be it for now. I'm hoping we can do similar things like this in the future. I don't know if you have big updates. We can go through and look at the changes and talk about them and you know, give people a closer look at, you know, what is actually changing. A lot of times you'll say, well, I made some changes, and people won't really know what those changes were or how they worked. And you do the great blog posts. The blog posts are awesome. And maybe in the future we can do some little videos about them as well. That'd be
Yeah, definitely. Yeah, and people who listen to this either now or possibly if this makes its way to YouTube, yeah, let us know if you find this interesting or not, or if there's other things you'd want to hear about.
very good. All right, Dumbmatter, Feather, thank you both for your time, and we'll catch you later.
Yeah, thank you too.
And that is going to be it for the stream right now. So I hope you all enjoyed this. I'm really thankful for Dumbmatter to take time out of his Sunday to do this and explain everything. So that was really special. And that's the end of the stream. I gotta go. I'll catch y'all later. Peace.
Thanks for hosting.